Diesel engines have powered the world for decades, but stricter EPA emissions rules changed everything. Some of the most legendary engines, known for their toughness, reliability, and simplicity, couldn't adapt from classic workhorses to high-tech behemoths. These 12 diesel engines were all iconic in their day, and all ultimately sidelined by regulations. 1. Cummins X Series. Cummins created the ISX family because older engines like the N14 simply couldn't keep up as EPA emission standards became stricter, especially heading into the 2000s. The ISX changed a lot over the years because each new rule meant Cummins had to rethink how the engine handled fuel, air, and emissions. Early versions used a dual overhead cam setup, where one cam handled injection and the other ran the valves. They also used the EPA fuel system, which relied on cam-driven injectors and an integrated fuel module to control pressure and timing. By 2002, Cummins added cooled EGR to cut NOx, although that system kept getting more complex as requirements increased. In 2008, the ISX jumped to the CM871 generation with a DPF and DOC, which meant it could capture soot and burn it off during regeneration. Some motorhome editions even pushed up to 650 horsepower. When the EPA 2010 standards hit, the ISX 15 CM2250 arrived with updated EGR, a DPF, and SCR using diesel exhaust fluid. This is also when Cummins ditched the injector camshaft and switched to high-pressure common rail injection that could hit 35,000 psi. Even though the ISX family evolved a bunch, Cummins kept pushing forward, and by 2023 it introduced the X10 and the natural gas X15N. The X10 will eventually replace the X12 and L9, while the X15N is expected around 2025 to match diesel-level performance but with cleaner emissions. 2. Ford's 6.0-liter Power Stroke. The Ford 6.0-liter Power Stroke, which International Harvester built as the VT365, it ended up becoming a major reminder of how tough emissions rules can be when a company tries to take shortcuts, because Ford needed a cleaner successor to the famously dependable 7.3-liter Power Stroke for the 2003 standards. They relied on International to deliver an updated design, but what they got instead was a bunch of problems nobody expected. International tried to meet emissions requirements by focusing heavily on exhaust gas recirculation, or EGR, instead of creating a more complete after-treatment system. On paper, it looked smart because it kept the engine somewhat simple while reducing nitrogen oxide. Although that seemed fine in theory, the real-world results were a mess. The 6.0-liter quickly gained a reputation as one of the most troublesome diesel pickups ever. The EGR system pushed soot and moisture into places it didn't belong, so manifolds, EGR valves, and especially EGR coolers clogged constantly. Those coolers often cracked, letting coolant leak into the cylinders. And even though the engine could survive a lot, blown head gaskets weren't uncommon. The variable geometry turbo suffered too because carbon buildup made it stick or fail outright. So even with Ford's recalls and updated parts, the core issues stayed. That's why the aftermarket stepped in with bulletproofing, which fixed most failures. But doing it legally was another story. 3. Detroit Diesel Series 50. The Detroit Diesel Series 50 sits at the opposite end of the diesel world because it showed how a compact engine could deliver far more power than its size suggested, even though emissions rules eventually pushed it out. This inline-4 displaced just 8.5 liters, so it was smaller than most of its rivals, but it still powered a bunch of city buses and medium-duty trucks through the 1990s and early 2000s. Unlike Detroit's old two-stroke legends, the Series 50 was a modern four-stroke with electronic controls. Its D-Dronic system gave it precise fuel delivery and strong diagnostics, which helped it make up to 350 horsepower and 1,150 pound-feet of torque. Impressive numbers for such a compact setup. Because of that, it could easily compete with much bigger engines, especially in stop-and-go city work. Transit agencies loved how smooth and quiet it ran, and its strong low-end torque made buses feel more responsive. But when the EPA's 2007 emissions rules demanded DPF and SCR systems, Detroit had to choose between redesigning it or walking away. Since the engine served a relatively small, specialized market, a full update didn't make financial sense. So production ended, leaving fleets searching for replacements that never quite matched what the Series 50 offered. 4. Cummins 903. The Cummins 903. A huge V8 built around the idea that plenty of displacement can handle almost any job. It delivered big torque and handled tough workloads without hesitation because its deep skirt block, oversized bearings, and forged crankshaft made it feel practically indestructible. A bunch of people even thought it was overbuilt for what it was meant to do. Its strongest reputation came from military duty. The 903 powered tactical trucks, construction equipment, and marine vessels that needed to survive brutal conditions. The mechanical fuel injection system helped a lot because it avoided electronics that could fail in the field. So although the engine was massive, it stayed simple in the ways operators cared about. Farmers appreciated it for the same reasons. Large tractors running the 903 could tackle heavy work consistently, and the engine didn't complain even when maintenance wasn't perfect. But its old-school design and huge displacement eventually clashed with modern emissions rules, because updating it would have been far too expensive for such a small market. Cummins discontinued it. Even though it slowly faded away, its tough, hard-working reputation stuck around. 5. Detroit Diesel 6571. The Detroit Diesel 6571 is often seen as the last fully perfected two-stroke diesel before emissions rules closed the door on the era of the screaming Jimmies. It showed how Detroit's old-school approach could mix raw power with real practicality, because its compact V6 layout made it great for medium-duty work while still feeling tough enough to survive almost anything when it was maintained properly. Its two-stroke design fired every time the piston moved, which doubled the power pulses compared to a four-stroke. So it delivered impressive power density along with that sharp, legendary sound. But its reputation came from more than noise. It was the combination of simple mechanics and heavy-duty parts that made operators trust it for work that would break a bunch of other engines, the 6 V71 used unit injectors that were easy to service, and the Roots blower kept air moving through the engine without much drama. Even though it could run for thousands of hours under steady load, the same traits that made it strong also meant it couldn't meet modern emissions rules. Because the scavenging process let a little unburned fuel escape, the engine produced that blue haze regulators couldn't ignore. So the two-stroke era eventually came to an end. 6. Cummins N14. The Cummins N14 became a standout engine in the 1990s because it landed right in that sweet spot between old-school mechanical toughness and dependable highway performance. It delivered steady torque and long-lasting reliability, so it quickly became a favorite among fleets and owner-operators who needed an engine that could rack up endless miles without causing a bunch of costly surprises. Since it evolved from the older NTC series, it carried proven ideas forward, and the early N14 versions stood out because they combined solid power with simple mechanics. The PT fuel system kept pressure consistent and let each injector handle its own cylinder, and because there weren't any sensors involved, diagnosing issues stayed incredibly straightforward. The N14 was built for demanding highway life, with a deep skirt block, 7 main bearings, and a forged crankshaft that made it perfect for constant, heavy workloads. Its wet liner setup also kept rebuilds practical. So many N14 crossed 1 million miles, often after a couple of overhauls. Even though it wasn't as modern as upcoming electronic engines, it still balanced power and fuel economy well. Later electronic select models added some precision, but they also added complexity, putting the engine in an awkward middle ground. And once the 1998 emissions rules arrived, the N14 simply couldn't keep up its mechanical fuel system, and older combustion style weren't capable of meeting the new standards. So Cummins shifted to the ISX, marking the end of the Era 7. Caterpillar C15 ACERT. The Caterpillar C15 ACERT is often remembered as CAT's bold attempt to meet emissions rules by perfecting combustion inside the engine, instead of relying on a bunch of external after-treatment parts. CAT wanted cleaner burning through precise control, and because of that, ACERT used multiple fuel injections, variable valve timing, and advanced electronics to fine-tune how the engine handled pressure and temperature. Although the idea looked clever, it turned into one of CAT's toughest challenges once real-world driving came into play. Even though the concept sounded great, the C15 ACERT struggled with major heat issues. The constant micro-injections and exact timing pushed the cooling system hard, so overheating, head gasket problems, and fuel system wear became common, and because ACERT was so complex, repairs often needed specialized tools, which made life difficult for independent shops. Fuel economy also disappointed operators. Instead of improving efficiency, the engine sometimes burned more fuel because the complicated combustion process didn't always stay perfectly balanced. So by the time EPA 2007 standards arrived, CAT realized ACERT wouldn't be enough. Meeting the new rules would have required costly redesigns, so the company stepped away from the on-highway market, leaving ACERT mostly for off-highway work. A clear example of how tough the emissions transition really was. 8. Navistar's MaxxForce engines became one of the biggest gambles in diesel history, and ultimately one of its most spectacular failures. When EPA 2010 standards demanded huge reductions in nitrogen oxides and particulate emissions, most companies switched to selective catalytic reduction with diesel exhaust fluid. But Navistar decided to go all in on an EGR-only strategy because they believed customers wouldn't want to deal with DF. The MaxxForce 7 and MaxxForce DT engines used massive exhaust gas recirculation rates, sometimes up to 40%, to keep combustion temperatures low enough to limit NOx formation. Although it looked bold at first, the problem showed up quickly. The extreme EGR levels caused heavy carbon buildup throughout the intake system, clogging manifolds, valves, and especially EGR coolers. Those coolers began failing at alarming rates, sometimes before the truck even crossed 100,000 miles. And many failures poured coolant straight into the combustion chambers. Destroying the engines, fleets started experiencing failure rates they had never seen before. Some trucks needed major repairs or complete replacements before hitting 200,000 miles, which was unacceptable for commercial diesels expected to last far longer. By 2012, Navistar had to abandon its EGR-only approach and adopt SCR systems like everyone else. But the damage was done, and the company ended up paying hundreds of millions in settlements while losing market share to competitors whose engines had far fewer problems. 9. Detroit Diesel 8 V92. The Detroit Diesel 8 V92 deserves recognition as the peak of Detroit's two-stroke diesel engineering before emissions rules pushed the technology out of existence for good. This 8-cylinder beast mixed Detroit's raw two-stroke power with the durability that allowed their engines to dominate heavy-duty applications around the world. Like the 6 V71, the 8 V92 relied on unit injectors that could be individually serviced, timed, and replaced without electronic tools. What made the engine legendary was how it combined that simplicity with impressive output. 318 horsepower from 568 cubic inches, thanks to the efficiency of firing on every stroke. The engine's trademark sound came from that constant cycle, and the mechanical roots blower helped keep airflow strong, and scavenging clean fleet operators loved how the 8 V92 thrived under heavy loads and constant high-speed driving, especially in trucking and marine applications. But just like the 6 V71, its two-stroke design eventually ran into emissions laws it couldn't overcome. The visible smoke and unburned hydrocarbons were impossible to eliminate without dismantling the characteristics that defined the engine. So Detroit Diesel retired the line as the industry moved on. 10. Caterpillar 3406E. The Caterpillar 3406E, which many people still consider the greatest pre-emissions highway diesel engine ever built. It delivered an almost perfect balance of early electronic sophistication and old-school mechanical durability. This 893 cubic inch inline six represented the peak of CAT's mechanical heritage, showing how decades of heavy equipment experience could combine with modern controls without sacrificing toughness. CAT designed the 3406E with the expectation that it would be rebuilt multiple times. So they made the components easy to service and replaced the deep skirt block. 7 main bearings and strong head bolts created a combustion seal that could handle intense pressure. Its fuel system blended mechanical reliability with electronic precision, and unlike newer engines, it could still keep running even if its electronics failed. With up to 425 horsepower and 1,615 pound-feet of torque, the engine delivered power, fuel efficiency, and a long service life that often passed 1 million miles before needing major work. But when EPA 2003 standards arrived, the engine's core design couldn't adapt without sacrificing the reliability people loved. CAT chose to discontinue it instead of compromising its identity, and nothing that followed managed to recapture the same balance of performance, durability, and simplicity. 11. Detroit Diesel Series 60. The Detroit Diesel Series 60 ended up being one of those engines that defined an entire era, but its long run eventually had to wrap up because emissions rules in the 2000s kept tightening. The shift pushed Detroit Diesel toward newer DD platforms with more advanced after-treatment systems. When the Series 60 first showed up in 1987, it immediately stood out since it was the first heavy-duty diesel engine to come with fully integrated electronic controls, which was a big deal at the time because most engines were still relying on mechanical setups. Detroit originally recommended overhauls at around 500,000 miles, although the engine proved itself so well that they bumped that interval to 750,000 miles. The 11.1-liter version, which was popular in 1993, especially in buses, was rated at 350 horsepower, and it could even squeeze out about 15 more when cruise control was on. The Series 60 worked as a 4-stroke inline-six and also introduced an overhead camshaft and full drive-by-wire control, which made it feel more modern than a bunch of competing engines at the time. Alongside the 11.1-liter model, Detroit also offered a 12.7-liter version created by giving the engine a longer stroke, and both of these sizes found homes in trucks, coaches, and tractor-trailers. The 11.1-liter was discontinued in 1998, so the 12.7-liter took over in most motor coach setups. Even Neoplan buses started offering the Series 60 in their articulated models toward the late 90s. Detroit eventually expanded the engine into marine use in 1999, with wider production shortly after, which showed how versatile the platform really was. 12. Perkins 6354. The Perkins 6354 represents everything people still admire about classic British diesel engineering. It came from a time before strict emissions rules and before simple, rugged engines were replaced by complicated systems. Because it was developed in the late 1950s, it carried that old-school idea that reliability mattered more than chasing big performance numbers. This naturally aspirated inline-six displaced 354 cubic inches, and it quickly turned into a global workhorse. It ended up in a bunch of agricultural and industrial machines, from Massey Ferguson tractors to generators and forklifts, spreading across 6 continents. Although it was never marketed as some groundbreaking innovation, it quietly became one of those dependable legends people still trust. Even though the 6354 wasn't about big horsepower and usually made between 85 and 120 horsepower, depending on the application, what really made it special was its design philosophy. Perkins built it expecting owners to push it through harsh conditions for decades, so the engineers focused on long-term durability. Features like direct fuel injection and a toroidal piston chamber helped improve efficiency without adding complexity. One of the biggest selling points was its wet sleeve design, which made rebuilds far easier and cheaper because operators could replace worn sleeves instead of removing the whole engine. That, along with a simple mechanical fuel injection system, meant most mechanics could keep it running with basic tools. So even though it eventually faded from emission-regulated markets, it's still working hard in places where the rules aren't as strict, proving solid engineering really lasts. And that's that for today's video. Thanks for watching, and we will see you in the next one.